Hey everyone, and welcome back for another deep dive. This time we are taking a look at some really cool new images from the inner solar system. It's of Mercury, that little planet that's basically right next to the sun. And we're talking about the latest from the ESA's Bepi-Colombo mission.
Yeah, they just finished another flyby.
Snagged some incredible close-up images.
Oh, yeah.
And they've actually made a few surprising discoveries, too.
I think what's really fascinating about this mission is it's giving us this really up-close look at, one of the most extreme environments in our solar system. Bepi-Colombo was just a few hundred kilometers away.
Wow.
When it took these photos. So, the level of detail is amazing.
Okay, but before we get too into the images themselves, can we just do a quick Mercury 101? I feel like most people probably remember it's small.
Uh-huh.
And it's hot, but that's about it.
Yeah, you're right. It doesn't really get as much attention as some of the other planets.
Right.
So to put things into perspective, Mercury is the smallest planet in our solar system and the closest to the sun. It's rocky. It's cratered kind of like our moon, but with way more dramatic temperature swings.
Wait, how dramatic are we talking? I remember learning about that back in school, but it's all kind of a blur now.
So imagine this. During the day, the surface temperature on Mercury can reach a scorching 472 degrees C.
Oh, wow.
Hot enough to melt lead.
Yeah.
But then at night, it drops to a freezing -200 degrees C.
Oh, my God.
That's a temperature difference of over 670 degrees.
Wow. That's wild. I can't even imagine what it would be like to experience that kind of temperature swing in a single day.
Yeah.
No wonder it's called an extreme environment.
And to make things even more difficult for us Earth-bound observers, Mercury is always hanging out near the sun, making it really hard to observe from Earth.
Yeah.
It's like trying to spot a firefly that's buzzing around a spotlight.
That makes sense.
Yeah.
So is that why the Bepi-Colombo mission is such a big deal then? Because it can actually get up close and personal in a way that we never could from Earth?
Exactly. And it's not just a quick flyby mission either. Bepi-Colombo is using these close passes to adjust its trajectory, kind of like a gravitational slingshot. So it can eventually settle into orbit around Mercury in 2026.
That's a long game. It seems like a lot of planning and patience goes into these space missions.
Absolutely. And it's not just the ESA behind this mission either. Bepi-Colombo is a joint effort between the European Space Agency and JAXA, the Japan Aerospace Exploration Agency. It's a really cool example of international collaboration in space exploration.
I love hearing about these kinds of partnerships. Okay,
Yes.
I'm ready to see what they've captured. Let's talk images.
Yeah.
What's the first one that really stands out?
The first one that grabbed my attention was taken right at Mercury's terminator. Now, the terminator is that line that separates day from night on a planet. And this image shows some of the permanently shadowed craters at Mercury's North Pole.
Wait, permanently shadowed craters? On a planet that's hot enough to melt lead during the day? What's going on there?
Yeah, it seems counterintuitive, right? But these craters are so deep and the rims are so high that sunlight never actually reaches their floors.
Wow.
And because of that, they stay incredibly cold, cold enough to harbor ice.
That is mind-boggling. Ice on a planet where you could bake cookies on the surface during the day. It just seems like Mercury is full of contradictions.
Yeah.
And the image actually labels some of these craters by name, right?
Yes, you can see Prokofiev, Kandinsky, Tolkien, and Gordimer. It's almost like a map to the most exclusive and coldest real estate in the solar system.
I like that. A map to the most exclusive real estate.
Yeah.
Okay, what about the next image? What does that one reveal about Mercury?
This one takes us to a totally different region called Borealis Planitia,
Okay.
a vast plain that was formed by volcanic activity billions of years ago. At first glance, it might look a bit like the moon's surface, but if you look closely, you'll see evidence of a much more dramatic past.
So you're saying Mercury isn't just a barren rock. It had actual volcanoes erupting at some point.
Oh, absolutely. Billions of years ago, Mercury was a hotbed of volcanic activity. Massive eruptions spewed lava across the surface,
Wow.
creating these vast plains. We can see evidence of this in craters like Henri and Lismore, which were completely filled in by the lava flows, leaving behind just a faint outline.
It's like a snapshot of a planetary Pompeii frozen in time.
Yes.
So what else can we see in this image?
Aside from those filled-in craters, you can also see these interesting wrinkles across the plains.
Okay.
They formed as the planet cooled and contracted, kind of like the skin of an apple as it shrinks.
That's a great visual. So are we looking at an ancient inactive surface now, or is there any hint that things might still be happening beneath the surface?
That's a great question, and luckily the next image provides some clues. This one features a region called Nathera Facula. which is essentially the aftermath of Mercury's largest volcanic explosion.
Wait, Mercury has volcanic explosions? I thought it's all ancient history with the volcanoes.
Well, it might be small, but it's definitely not inactive. Picture this. A central vent, 40 kilometers across, erupting with enough force to send lava flowing for over 150 kilometers. Talk about a planetary fireworks show.
That is seriously impressive. 40 kilometers. That's like an entire city being swallowed up by a volcanic vent. It really puts things into perspective.
And to highlight just how dynamic Mercury's surface still is right next to this ancient eruption site, we can see the Fontaine crater, which is a mere 300 million years old. A baby in geological terms.
Wow. So even on a planet as seemingly desolate as Mercury, things are still happening. I'm starting to realize just how much we still have to learn about our closest planetary neighbor. But before we get too ahead of ourselves, I'm curious about the bigger picture here. What does all of this tell us about the evolution of planets, including our own?
That's an excellent question, and it's one of the key reasons we study Mercury in such detail. It acts as a window into the early solar system, helping us understand how rocky planets form and evolve.
Okay, I'm all ears. What can this tiny scorching planet tell us about the grand scheme of things?
So by studying Mercury, we can actually learn about the fundamental processes that shaped our own planet, like volcanic activity and the effects of impacts. We can also get clues about how planets interact with their stars and how those interactions can influence things like a planet's atmosphere.
So by understanding these extreme environments, we can gain a better understanding of how planets in general work, even the ones that aren't quite so extreme.
Exactly. And Mercury's close proximity to the Sun makes it an ideal subject for studying these processes. Plus, its small size means it cooled and contracted way more quickly than larger planets, leaving behind evidence of its early evolution that might be harder to see elsewhere.
I'm starting to see why this little planet is such a big deal for planetary scientists. But you mentioned the effects of the Sun, and that makes me think about Mercury's magnetic field. I remember learning that it has one, but it's much weaker than Earth's.
Yeah, you have a great memory. And that weaker magnetic field is another aspect that makes Mercury so intriguing. Remember how we talked about Bepi-Colombo having two orbiters? Well, one of them, the Mercury Magnetospheric Orbiter, built by JAXA, is specifically designed to study the planet's magnetic field.
Okay, two for the price of one. That's pretty cool. But why is studying Mercury's magnetic field so important? What can it tell us?
Well, you see, a magnetic field acts like an invisible shield around a planet, protecting it from the constant stream of charged particles coming from the sun, what we call the solar wind. Earth's magnetic field is quite strong, so it does a pretty good job of deflecting most of that radiation.
So what you're saying is that Mercury's magnetic field is kind of like the leaky shield. Does that mean the planet is constantly bombarded by solar radiation?
That's a great way to put it. And yes, that constant exposure to the solar wind can have a big impact on a planet's atmosphere and even its surface. It can strip away atmospheric gases and alter the composition of the surface rocks over time.
That makes you wonder what it would be like to stand on the surface of Mercury, doesn't it? Talk about a harsh environment.
Yeah.
But back to the science. How does studying this weaker magnetic field help us understand other planets?
That's where things get really interesting. By comparing Mercury's magnetic field to Earth's, we can start to understand how the strength and structure of a magnetic field influence a planet's ability to hold on to its atmosphere, and how that in turn might affect its potential for habitability.
So it's not just about Mercury itself. It's about what we can learn about the habitability of planets in general, right? Especially if we're thinking about searching for life beyond Earth.
Exactly. By studying the extreme cases like Mercury, we can gain a better understanding of the factors that contribute to a planet's ability to support life as we know it. It helps us refine our search criteria as we look out at other star systems.
That makes a lot of sense. Okay,
Yeah.
I'm officially fascinated by this little planet. But you mentioned that Mercury's magnetic field can also tell us about what's happening deep inside the planet. How is that possible?
Well, the prevailing theory is that Mercury's magnetic field, like Earth's, is generated by a molten iron core. But Mercury's core is proportionally much larger compared to its overall size. By studying the magnetic field's strength and variations, we can get clues about the size, composition, and activity of that core.
So it's like a planetary MRI, giving us a glimpse into the heart of Mercury.
Precisely. And understanding the dynamics of a planet's core is crucial for understanding its overall evolution, including things like volcanic activity and the formation of its magnetic field in the first place.
Wow, it seems like every detail we learn about Mercury just leads to more fascinating questions. But before we get too lost in the mysteries of the interior, I want to circle back to something you mentioned earlier. The idea that Mercury's orbit played a key role in confirming Einstein's theory of general relativity. Can you explain that a bit more? I have to admit, physics isn't exactly my strong suit.
Of course. This is where things get a bit mind-bending, but I'll try to keep it simple. For centuries, scientists used Newton's laws of gravity to explain the movements of planets, and those laws worked pretty well for most planets, but Mercury's orbit was a bit of a puzzle.
Okay, what was so strange about Mercury's orbit?
It all comes down to a tiny wobble. Astronomers noticed that the point in Mercury's orbit where it's closest to the Sun, called the perihelion, was shifting slightly over time.
So it wasn't following a perfectly predictable path like the other planets.
Exactly. And this tiny shift couldn't be explained by Newton's laws of gravity alone. It wasn't until Einstein came along with his theory of general relativity that we had a new framework to explain this strange behavior.
So Mercury's wonky orbit provided evidence for one of the most groundbreaking theories in physics. That's incredible. It really makes you realize that even the smallest, seemingly insignificant details can have profound implications.
Absolutely, and that's why we keep exploring, keep observing, and keep asking questions. Because there's always something new to discover, something that might challenge our assumptions and push the boundaries of our understanding.
I have to admit, the more we talk about Mercury, the more amazed I am by this little planet. It's a reminder that there's still so much we don't know about our own solar system, let alone the vast universe beyond.
You're absolutely right, and that's what makes it so exciting. Every mission, every discovery brings us closer to understanding our place in the cosmos.
Well said. So what's next for Bepi Colombo? Does it have any more tricks up its sleeve before settling into orbit in 2026?
Well, it has a few more flybys scheduled over the next couple of years, and each one will provide new opportunities to gather data and capture even more detailed images. We can expect to learn a lot more about Mercury's surface, its magnetic field, and its overall evolution.
That's exciting news. I can't wait to see what else they uncover. But while we wait for those future discoveries, can we dive back into some of the details from these recent images? I'm curious to learn more about some of the unique features on Mercury's surface.
Oh, you're in luck, because there's one feature in particular that really stands out. Have you ever heard of Mercury's scarps?
Scarps? I can't say that I have. Is that some kind of space jargon I need to brush up on?
Not really jargon, but maybe not a term you hear every day.
Okay.
So basically, scarps are these long, steep cliffs that run for hundreds of kilometers across Mercury's surface. They're like giant wrinkles on a planetary scale.
Giant wrinkles, huh? Now that's an image I can get behind.
Yeah.
How did these scarps form? Did they happen all at once, or is it a more gradual process?
Scientists believe that they formed over billions of years as Mercury cooled and contracted. It's kind of like what happens when you bake a cake. As it cools, the outer layer shrinks and cracks, forming those little fissures around the edges.
Oh, I see. So it's like Mercury is a giant space cake that's been slowly cooling and wrinkling for billions of years.
A very simplified way to put it, but yeah, you've got the basic idea. And these scarps are really fascinating because they provide evidence for the incredible forces at work inside planets as they evolve.
It makes you wonder what other hidden features are waiting to be discovered on Mercury's surface. But speaking of unique features, we can't forget about Mercury's kind of unusual orbit.
Right.
It's not perfectly circular like most planets, is it?
You're absolutely right. It's way more elliptical or oval-shaped than the orbits of other planets in our solar system. We call this its eccentricity.
Eccentricity, that's a good word for it. So what makes Mercury's orbit so eccentric? And does it have any implications for how the planet interacts with the sun?
Well, there are a few theories about why its orbit is so elliptical, but the most likely explanation has to do with gravitational interactions with the other planets in the solar system, especially Jupiter. Over billions of years, those gravitational tugs have slightly stretched out Mercury's orbit, giving it that distinctive oval shape.
It's amazing to think that something as massive as Jupiter can influence a tiny planet like Mercury from so far away.
Yeah.
But, you mentioned earlier that this unusual orbit actually played a role in confirming Einstein's theory of general relativity. That sounds like a pretty big deal for such a small planet.
It really is. So you see, according to Newton's classical laws of gravity, Mercury's orbit should have been stable and predictable.
Okay.
But astronomers noticed that the point in Mercury's orbit that is closest to the sun, it's called the perihelion, was slowly shifting over time. This shift is called precession, and it was too large to be explained by Newton's laws alone.
So it was like Mercury was doing a little cosmic dance, wobbling off course in a way that classical physics couldn't quite explain.
Exactly. And this tiny wobble had astronomers puzzled for decades. It wasn't until Einstein published his theory of general relativity in 1915 that they finally had an explanation.
Okay, I'm going to need you to break this down for me a bit.
Yeah.
How did Einstein's theory solve the mystery of Mercury's wonky orbit?
Okay, so in a nutshell, Einstein's theory predicted that massive objects, like the sun, actually warp the fabric of space-time around them. And this warping creates a slight curvature in the path of anything traveling near that massive object, including light itself.
So it's not just that the sun's gravity is pulling on Mercury, but it's also like distorting the very space that Mercury is traveling through.
That's right. And this warping of space-time is what causes the precession of Mercury's orbit. Einstein's calculations perfectly matched the observed shift, providing one of the first major confirmations of his revolutionary theory.
Wow, that's incredible. So this tiny planet, often overlooked and overshadowed by its larger, more glamorous neighbors, actually played a key role in revolutionizing our understanding of gravity itself.
It just goes to show that there's always something new to learn, even from the places we think we know best. And that's why missions like Bepi Colombo are so crucial. They're not just about confirming what we already know, they're about pushing the boundaries of our understanding and uncovering new mysteries.
Well said. You know, it's funny how we often talk about space exploration in terms of the big picture, like searching for life on other planets, understanding the origins of the universe and things like that. But sometimes it's these smaller details, these unexpected discoveries that really capture our imaginations.
I completely agree. Those little quirks and anomalies are often the ones that lead to the most profound insights. Who would have thought that a tiny wobble in Mercury's orbit would have such a massive impact on our understanding of physics?
Exactly. And who knows what other secrets Mercury is hiding? What other mysteries are waiting to be unraveled as we continue to explore this enigmatic planet?
That's the beauty of science, isn't it? There's always more to learn, more to discover. And as we continue to explore our solar system and beyond, we're bound to find even more surprises, more questions that need answering, and more reasons to marvel at the complexity and beauty of the cosmos.
It's been a really fascinating journey, exploring the fiery landscapes, icy secrets, and mind-bending physics of Mercury. From scorching temperatures to hidden ice, volcanic eruptions to a wonky orbit that helped prove Einstein right, this tiny planet has certainly proven that size isn't everything.
Indeed. It's a testament to the idea that every corner of our universe holds wonders just waiting to be discovered. And it's a reminder that the pursuit of knowledge and understanding is an ongoing journey, one that we're all privileged to be a part of.
Well said. And on that note, I think it's time for us to wrap up our deep dive into the wonders of Mercury. But before we go, I want to leave our listeners with a thought. If this tiny, scorching planet can hold so many surprises, imagine what other incredible discoveries await us out there in the vastness of space. So keep looking up, keep asking questions, and never stop exploring. Until next time, clear skies.